Okay, so I posted earlier a solution to one of our problems from worksheet 3. Well, here's a solution to one of the problems from worksheet 4. Again, I just did the first one. It gives you a general gist of what's going on. Again, if you want any other problems or anything in particular, just let me know. Send me an email or come to our Zoom meeting here in a little bit. So this is the first problem from worksheet 4. It says, old cannons were built on wheeled carts, both to facilitate moving the cannon and to allow the cannon to recoil when fired. When a 150 kilogram cannon and cart recoils at 1.5 meters per second, at what velocity would a 10 kilogram cannonball leave the cannon? So the first thing is to set up our conservation of momentum diagram for what's going on. So at the beginning, I have the cannon and the cannonball together as one thing. I'm thinking of this as the cannonball being stuck in there. And at the beginning, neither of them are moving, so my momentum is 0. At the end, that means that my momentum has to add up to 0 at the end. So the cannon, we know that it recoils. So because it recoils, I had that as a negative value. And I just gave it a -2 value. It doesn't matter, -1, -2, -3, -4, it's all the same. Just as long as the cannonball matches that, except it's in the opposite direction. Okay, and since it's being fired, I thought of that as the positive direction. So there it is, my cannon and cannonball momentums after it has been fired. Okay, and again, if you notice, -2, +2, they add up back to 0, which is what I started with. So I am observing the conservation of momentum. So then I listed out my values. My first mass is that of the cannon, 150 kilograms. My first velocity, or my V1, would be the -1.5 meters per second. Again, that's the velocity of the cannon. And it's negative because, again, recoiling. Recoiling means going backwards. So I'm thinking that is negative. My second mass is that of the cannonball, which is 10 kilograms, and we don't know its final velocity. So next, going to my conservation of momentum equation. My starting momentum has to equal my ending momentum. So at the beginning, I have the two masses together at some initial velocity, and it was at rest, so we know that's going to be 0. And that'll be equal to the ending, and they end separate, so M1V1 plus M2V2. Again, I know that my initial is 0 because it's not moving. So that means 0 has to equal out my initial, my cannon plus my cannonball. So I'm going to rearrange that so that now my negative M1V1 equals M2V2. And because I'm asked to find the velocity, I went ahead and rearranged that formula to solve for the velocity. Part C, go ahead and figure out the velocity. So again, I'm using that same formula that I just had. V2 will be negative M1V1 over M2. I plug in my values. Again, my velocity has to be negative because it's moving in the negative direction. So I plug in again my values, M1, V1, M2. Do math, solve, I get my final velocity. And again, make sure that it's positive because it has to be in the opposite direction of the cannon, which gives me my 22.5 meters per second. Again, if you have questions, let me know. Hope this finds you well. Have a good one, y'all.